Welcome dear learners, I am Mr. Abhijit. Welcome to my channel Chemistry Learners. In this lecture, we are going to learn about resonance effect. So what is resonance effect? That we will see first. So the effect which is operating in aromatic compounds, and it is actually, this decides the stability of aromatic compounds and the reactivity towards the substitution reaction mostly, because aromatic compounds almost undergoes substitution reaction. So it decides the stability and reactivity of aromatic compounds. So what is this? Resonance effect is nothing but the polarity which is produced in molecule due to interaction of lone pair of electrons and pi bond. So this is nothing but the interaction or movement of electrons in between the pi bond and in between the sigma bond. So it is actually having some of the system that is to be required for this resonance effect is nothing but the conjugated system, then delocalization of electrons which can be takes place in pi bonds via single bond. So what is this resonance effect? So let us see this with the help of example of benzene. So this is the structure of benzene, and this resonance effect, or whatever the resonance structures we are going to explain here, that can be shown by this double-headed arrow. This double-headed arrow shows the two structures. Whichever two structures are there, they are in equilibrium with each other, or they are similar to each other. Okay, so let us see this resonance structure in the benzene. So whatever this first bond is there, that is going to rupture towards this bond or towards this carbon atom. So this pi bond preferably going to break, and there is a formation of positive and negative charge. So here if you see, this bond is broken. Where this bond is broken towards this another carbon atom. If this is broken here, so what happens? Negative charge is formed at this carbon and this becomes the positive. So what happens? Again in the next step, what happens? This negative charge is going to shift in between these two carbon atoms, and there is a formation of double bond. Okay, then in the next step what happens? The next double bond is going to break, and there is a formation of negative charge here on this carbon atom. So what is the next structure? If you see, this next structure is, so this is double bond which is going to form, and this is the next structure. Okay, so here negative charge is formed on this carbon atom. If you see this bond or the head of this arrow, that is going towards this carbon atom, and there is a formation of negative charge. So again this negative charge is going to form a double bond or a bond in between these two carbon atoms, and the next bond is going to break. Okay, so it is going to break. So let us see again, this is the bond, and this is again going to break towards this carbon atom. So this is the formation of, let us see again. So this is the formation of negative charge here and positive charge as it is. So in the next step what happens again? This negative charge is going to form a bond, and there is a neutralization takes place here, positive and negative charge, and there is a bond formation between these two carbon atoms takes place. So in this way you can draw the structure of benzene with the help of this resonance effect. Then what are the properties of this resonance effect? If you see, it is always present in the aromatic compounds and gives the stability to the particular aromatic compound or the molecule, and then it decides the stability or again the reactivity of aromatic compounds. Then What are the types of resonance effect? So there are two types of resonance effect. Again, as like inductive effect, there are two types of resonance effect. Electron donating resonance effect, that is also denoted by plus R effect, and then electron withdrawing resonance effect, that is also denoted by minus R effect. Let us see this in details. So again, electron donating resonance effect, that is plus R effect. Here the electrons or the benzene ring is attached to the electron donating group, that we can say as a EDG. Then electron donating group activates the ring. Then negative charges are occurred on ortho and para position on the ring. So these are the very important things that to be remembered. Then what are the different examples of electron donating groups? That is, the elements which are having higher electronegativity as compared to carbon are electron donating in nature. So what are those groups? OH group, that is in phenol, NH2 group, that is in amines, SH group, that is in thiols, then X means all the halogen atoms, R group, actually here it is going to give electrons with the another effect, then this OH group, OR group, that is ether group, they are all having higher electronegativity as compared to carbon, and they are attached to the ring, then they show electron donating nature and activates the ring. Then resonance effect in phenol. So now here we are considering electron donating group and its resonance effect. So as this phenol structure is considered, this benzene ring is attached to the OH group, and whatever this oxygen is there, it is having more electronegativity, so it gives electrons to the benzene ring. So these electrons, donation of electrons can be given with the help of this arrow. Okay, if you see this arrow, these electrons are transferred here. Let us see again. Okay, so the electrons are transferred to this carbon atom, and when these electrons are transferred to this carbon atom, what happens? Here it is going to form a double bond, then this double bond is going to break and the negative charge is formed on this carbon atom. So electrons are donated to the chain, to the benzene ring. Then here, if you see these changes in structure, here the double bond is formed, then negative charge is formed here, and OH is going to form a positive charge. Okay. Again, now if we shift this negative charge in the benzene ring, so in this way it is shifted, and next double bond, which is in conjugation, is going to form negative charge on this carbon. So here it is the next structure which is formed here. Again, if you shift this negative charge in ring and break this double bond, alternate double bond, or which is the bond which is in conjugation, then there is a formation of such type of structure. Okay, so this type of structure. So again, next step, in the last step, what happens? The double bond is again going to form in the benzene ring, and it is going to break. So this is the final structure. If you see the changes, the double bond and single bond are altered in the final structure. So this is nothing but the resonance in phenol. If you do the more and more practice of drawing these structures and moving these electrons into the benzene ring, then you are going to get mastery in these particular resonance structures. Then electron withdrawing resonance effect. This is also called as minus R effect. So this is when electron withdrawing groups are attached to the benzene ring, then this effect can be shown. Then electron withdrawing groups actually deactivates the ring, because on benzene ring itself is an electron cloud. So if electron withdrawing group is there, it withdraws the electron density from the benzene ring and ring becomes positive in nature. So the positive charge occur on the ring. So what are the examples of electron withdrawing group? So these are nothing but the double bonded elements or group of elements which are having double bonds, alternately double or triple bonds. If you see all the structures here, so this is the aldehyde, carboxylic acid, this is ketone, this is alkene group, this is alkyne, this is cyanide, this is ester group, nitro group, amides group. These are the groups which are showing double bond outside the ring. So whatever these double bonds are there, they are going to abstract the electrons, attract the electrons from the benzene ring. Let us see the example of resonance effect into the benzaldehyde. So in benzaldehyde, if you see the double benzene ring is there, then this benzene ring is attached to this carbon atom with single bond. Then after single bond, there is a quick double bond or triple bond is there. Then such type of system is electron withdrawing system. So whatever this group is there, this group is electron withdrawing group which withdraws the electron density from benzene ring. So let us see this structure. So what happens? Oxygen is more electronegative. That's why it is going to abstract the electrons towards itself by this resonance effect. Then electrons which are abstracted by the benzene ring towards this carbon atom, because this carbon becomes electropositive and it abstracts the electrons. Then next structure which is formed is like this. This is negative charge on the oxygen and benzene becomes positively charged at the ortho position. In the next structure, what happens? This positively to neutralize this positive charge, the next quick double bond is going to shift towards the positive charge, and again the positive charge is formed on the para position. Okay, again the next double bond is going to shift electrons. Then this is the positive charge which is formed at the again ortho position. This is the next structure, and this is the final structure which we are going to draw here, is shifting of this negative charge towards the again benzene ring to form aromatic benzene ring or aromatic compound. So it is formed like this. So this is the final structure. So what is the difference between this first and last structure is only the arrangement of double bonds into the benzene ring. So important things to remember in this plus R effect and minus R effect, that is resonance effect, is, so what is the plus R effect? So these are the key points. So this is ring activating effect, or ring activating groups are when attached to the benzene ring, it forms ring activating group. Then it activates the ring towards the ortho and para position. Then the negative charge is formed on the benzene ring. Always remember this trick, that in plus R effect, negative charge is formed on benzene ring. Then what about the negative R effect, that is minus R effect? That is, it is ring deactivating effect or group. Then it activates only meta position. Then positive charge is formed on the ring. Always remember again this trick, that in negative R effect or minus R effect, positive charge is formed on the ring. So in this lecture, what we have learned is resonance effect, its types, and the structures, that is different resonating structures among the molecules. So in this way, we are going to conclude this lecture. Thank you.